Okay, so recording now. And I'll show you the starter questions for the students who are watching this through YouTube. So the first question, what is 4.3 times by 6.7? Question 2, solve the equation. Question 3, calculate the height of the parallelogram, given that you know the volume, the area is 40 centimeters squared. Question 4, express 5 to 9 in the form 1 to n. Question 5, Venn diagram question. I'll leave this question on the screen for a moment or two. Question 6 is a two-way table. So copy the table down, fill in the missing numbers. Here, 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 and here. So 5 missing numbers. And then the last question, question 7, fractions of an amount. As it goes, most of you are on the last two questions. So once you finish the questions, just go back through your answers to make sure you've checked them and you're happy with what you've submitted. Even if it means doing the multiplication question one again, making sure you get the same answer as before. Making sure that you put your decimal places back in, things like that. Okay. Now, anything you're unsure about, don't worry. I'm going to go through each and every question. But obviously, we got to treat, because we are so close to the exams, we're literally a week away. We need to take these starters quite seriously, and we need to imagine they're actually exam questions, and we're practicing for the real thing. Okay. So look through them, make sure you're happy with your answer, and then look at the next question. Okay. So just double check what everything you've done. Happy days. Some really encouraging things like that I'm seeing on Desmos. So some really nice answers. So well done to those getting stuck in. And once again, thank you guys for spending your Tuesday morning with me, working through some of these topics and some of these questions. Thankfully, due to the advanced information, we can be quite prescriptive with the topics that are coming up. And like I say, some of these are definitely going to be something you'll see next Tuesday. So hopefully it's good preparation, good practice. I'll give you guys another 2 minutes, and then I will go through these questions. So give you yourselves 2 minutes now just to work through these questions, finish them off, try and get answers for each, and then we will review them as a team. Okay, guys, what to do now is bring your attention back to the PowerPoint, back to Teams. So can you drop a thumbs up in the chat, just so I know you're here and you're listening, you can hear me and everything like that, please. And Tom, don't worry if you've not managed to do them all. If you've just joined, then just do what you can. And it's It's the same for anyone. If you're unsure on a question, don't worry, don't panic. I'm quite relaxed when it comes to students doing work and stuff. I'm not like one of them guys who's like, you got to do everything, you got to get everything right. Just do what you can, and hopefully it's accurate. Right, let me go back to the start of the PowerPoint then, just so I can cover what I'm intending for us to do today. So next Tuesday, a week today, you'll be doing your paper 1, okay, your non-calculator paper. So this paper or this revision session is designed on that. So we're going to cover the starter questions. We're going to go through each one of those. Now, the reason why I gave you 7, which is quite a lot, is essentially because I want you to have lots of practice to do in maths. You're not going to get better at something just by watching other people do it. I think the more you do, the better your skills will develop. Now, I'm going to look at laws of indices today and looking at some of those advanced questions you might see in an exam. Now, they look horrible, but hopefully with my teaching today, you'll have more confidence for that. We're going to look at ratio again, because that's something that comes up, not in paper 1, but pretty much in every paper. And then we're going to look at amounts as percentages. So a bit of everything today, bit of variety. So hopefully it keeps you entertained. And hopefully after or about 12 o'clock today, you've left having learned something new. Quick reminder on the date. So paper 1 next Tuesday. Paper 2 is Thursday, and then paper 3 is Monday. So all 3 papers will be done in the space of a week, which is quite nice, because I know in the summer students didn't really like the fact they were spread apart so much. You'll have them all done in the space of a week, and then we wait for your results in January. Now, this is really important. These aren't internally set. We don't set them at reset saying, oh, we're doing it to decide these days. Every student who's doing the November reset will be doing it on this day, this day, and this day, and there's no chance, like there's no reset, there's no like, oh, I'll do it the next day. You've got to be there, okay? So make sure you set your alarms and everything like that. Right, guys, let's get look into these questions. So what is 4.3 times 6.7? So there's a few different strategies for multiplication. Now I'm going to show the grid method, because that's the sort of one that I always kind of opt to, and it seems to be quite popular. But first things first, let's just pretend the decimals don't exist. So we're going to treat it as 43 times by 67, because using decimals can be quite tricky at times. So if we get rid of those decimals, it makes our life a lot easier. Right, let me get used to this graphics tablet. Let's start again. Right, so 43 times by 67. Get rid of those decimal points, and we'll treat it as 43 and 67, okay? So 43, 67. So first things first, 4 times 6 is 24. There's 2 zeros, so chuck those 2 zeros in. 6 times 3 is 18. Chuck that 1 0 in from there. 7 times 4, 28. There's 1 0, and then 7 times 3 is 21. There's no zeros, so that can stay the same. Okay, now once we've got that, we need to get them all lined up, and then we're going to add them all up together. So 280, 180, and then 21. Now make sure you take your time to line them up as neatly as possible. The amount of times I see students accidentally put something in the wrong area and it costs them a mark, it breaks my heart. So 0, 0, 0, 0, 1, there we go, 1 at the end. 8 add 8 is 16, add 2 is 18, so carry the 1 over. 4 add 2 is 6, add the 1 is 7, add the other 1 is 8, and then finally 2 by itself. Now, 2881 is the answer to this question, but we want the answer to 4.3 times 6.7. So what we're going to do is look at how many decimal places there are. There's 1 decimal place there and another one there, so there's 2. So what do I have to do with the decimal point? Bring it back in 2 spaces. So it goes bang in the middle of the number, so it becomes 28.81. Now, multiplying decimals is in the advanced information. We know that's coming up. So if you've not quite had success with this topic here, with this question, practice. The good thing about this sort of question is that you could literally just write down any numbers. You could literally say, I'm going to do 3.2 times by 6.4, okay? You can do your answer, get your calculator out, and you can check it. So it's a dead easy sort of, topic to work on. But there we go. There's the answer, 28.81, guys. Okay, next question. Question 2. Solve 2 open brackets, x plus 10, close bracket equals 45. So we have to expand these brackets. Okay, so these brackets here, we need to get rid of them, and we do that by multiplying. So regardless, even if you're not sure what to do sometimes in terms of solving an equation, if you see a set of brackets, always expand them. So 2 times x is 2x, 2 times 10 is 20, so it's going to be 2x plus 20 equals 45. Okay, So that gets you 1 mark. Just for expanding those brackets gets you 1 mark. Now, the reason why I'm kind of highlighting this is because sometimes in an exam, there might be a question and it might be quite difficult. It might look quite confusing. But if there's a set of brackets that you can expand, just do it because it picks you up a mark, okay? Now we just need to solve this equation. So plus 20, we want to take it away. So we minus 20 from both sides. That leaves me with 2x equals 25. And then the last thing I need to do to get x by itself is divide by 2. And once again, we do that to both sides. That leaves me with x equals half of 25, 12.5. So 3 mark question solving that equation, 1 mark for expanding the brackets, a 2nd mark for subtracting the 20, and then for dividing by 2. So 12.5 for your answer there. And if you've left it as a fraction, 25 over 2, that is also fine. So if you've got an answer that is written like this, also happy days, gravy, or gravy, okay? Solving equations, that's going to be something I think that appears in like all 3 papers. So that's something to be aware of. Area of a parallelogram. So a parallelogram, just so we know what one is, has 2 pairs of parallel sides. So the top and bottom, they're parallel, and then the sides, they are also parallel. They will never touch, and they are equal in length, okay? Now, it says here, 40 centimeters squared is the area, okay? So I know 5 times by a number, which is the height, is going to be 40. So this comes down to my times table skills. What do we times 5 by to get up to 40? We times it by 8. So the height of this parallelogram must be 8 centimeters. Another way you could look at it is do 40 and then divide it by 5. And that gives you the 8 as well. So there's 2 different ways you can kind of look at that question to get the answer. Now it's important, let me just highlight, in order to work out the area of parallelogram is the actual straight height times by the base. None of this slanted rubbish. We don't care about slanted height. We only care about the actual straight height, the perpendicular height, the mathematical word is. So always make sure it's the actual height times by the base. Where 8 centimeters for that one. Now, this is a question that we've seen many, many times, and it's answered very interestingly amongst students. Some students leave it, and then those who answer it tend to have a strategy for it. But my strategy from the top is I write the 2 ratios on top of each other. So I've got 5 to 9, sorry, and then 1 to n. Okay. Now use the side with the 1 on. That's crucial because that tells me what I essentially need to do. How do I get from 5 down to 1? I divide by 5, and I do the same to the other side. Whatever I do to one side, I do to the other side. So my final answer is going to look like this: 1 dot dot for the ratio, and then 9 divided by 5. I'm going to leave it as a fraction, 9 over 5. Okay, so I'm going to do another one actually. Let's say we've got 6 to 5, okay, and we want it in the form, let's go for a different n to 1 this time. So it's the other side now, the 1 is. Which side has the 1? It's the right hand side, so I have to ask myself, how do I get from 5 down to 1? I divide by 5, and it's the same on this side. So my answer will be 6 over 5 dot dot 1. That is my final ratio. So it's all about using the side with the 1 on it and then leaving your answer with a little fraction in there, because then you don't have to worry about doing the awkward conversion into a decimal. If you have done it as a decimal, absolutely fine. It would look something like 1 dot dot 1.8. That's absolutely fine. But to make your life easier sometimes, leave it as a fraction. That's absolutely fine. We see it in the exam mark schemes. Leaving it as a fraction is a-okay. Now, I love Venn diagrams. This used to be something I didn't particularly enjoy until I understood why. Now I know how to do them. I actually quite like these questions. So it's like problem solving. Now, this is what I imagine most students do in an exam. So there's 30 students are asked if they have a brother or a sister. Put that information into this Venn diagram. 13 have both. So that goes in the middle, which I think we're all pretty good with. 21 have a brother. So people will go, oh, 21 over there. 16 have a sister. Happy days. And they think, right, I've done that. Happy days. I'll move on to the next question. Now, that was pretty easy, right? Now, it's a bit more complicated than that. And I'll show you why this is incorrect. There's 30 students asked. 21 add 13 is 34. Add 16, that's 50. So our numbers add up to saying there's 50 students. So straight away, it's like, hang on a second, something's not right. So we're going to start from the top. I'm going to explain step by step how we use this information to fill in this Venn diagram accurately. Now, if you want more practice of these, give me a shout because I can send you some pictures of them because we've done this before. And like I say, I want to make sure students are confident with this. So 13 have a brother and a sister. They have to go in the middle because they have both, right? So 13 in the middle, I'm happy with that. Now, this bit's important. 21 have a brother. So this is the brother circle. So I'm going to try and circle it as neatly as I can. Okay, that'll do. So in this yellow circle here, they're all the people who have a brother. Now, the number has to add up to 21 because it's the brother circle, has to add up to 21. Now, 13 of them are already in the middle. So I need another number here that adds up to, or that will allow me to add it to 8, add it to 13 to get up to 21. So the number is 8 because 8 add 13 is 21. So I've actually met that criteria now. 8 add 13, 21, perfect. Now, the same rule applies for the sister circle, okay? So I'm going to circle all the ones here. This is the sister circle. And it says here 16 have a sister. Because there's 13 already in the middle, I'm going to have to chat now, actually, guys. What do you think's the missing number then that I need to put in here? Remember, this circle in yellow needs to add up to 16. I've got 13 in the middle. What's that missing number? It has to be. Can't be anything other than 3. Because 13 add 3 gives me 16, which is exactly what I'm after. Okay? Has to be 3. Can't be anything else. So let me just delete those there. Now, if we have a little look then, 8 add 13 is 21. Add the 3 is 24. So I've actually got 24 people counted for now. There's 30 in total. So I've got 6 students that go on the outside of both circles. Those 6 students don't have a brother or a sister, so they're an only child. But now I've got a complete Venn diagram where all the numbers add up to what they need to add up, and they all add up to that magic number 30. Okay, so make sure, always start with the number in the middle, and then work out what happens to the other numbers next to it, because that number has a big impact on things, okay? So, like I said, if you're thinking, I want to practice more of those, give me a shout. I'll send you some pictures across, okay? They're dead easy for me to create, so I don't mind doing that for you all. Okay, 2 more questions to go. This is a two-way table. So basically, it's about using what you know to calculate what you don't know. And there's a few different ways you can do this, but it's about kind of realizing, well, this number added to this number have to add up to 30. So 22 add 8 gives me 30. You could also look at this number here. You could say, right, well, 62 take away 30 will give me this number because I know that. Add that gives me this. So this number here is 32. What we need a number here that adds 15 to get you up to 32. So that's going to be 17. And then you can just add across. So 17 add 22 is 39. 15 add 8 is 23. Now, the last check I would do is make sure those 2 numbers that you've just put in at the end add up to give you 62. 9 add 3 is 12. Carry the 1. Oh, look at that. Boom. Excellent. So I've got my 62 there. And like I said, just double check all these numbers add up to what they need to. 17 add 22 is 39. Good. 17 add 15 is 32. 15 add 8 is 23. 22. Yeah, look, everything there just fits. So just make sure, use what you know to help you find out what you don't know. And it's either additions or subtractions for two-way tables, okay? Now, this next question, what is the probability that a year 8 student is early? Take a time. We only care about year 8 students, okay? Remember, look, it says here year 8 students. So we don't care about the year 7s. We don't care about the total number of students. We only care about these lovely year 8s. Now, how many year 8s are there in total? 30 of them. So it's going to be out of 30. Now, it says early. That's the crucial word there. So early, there's 22 of them that are early. So it's going to be 22 over 30. Now, you don't have to worry about simplifying it. The question doesn't say give your answer in its simplest form or anything like that. It just says what is the probability. Now, probability can be written nice and comfortably as a fraction. Work out the total number of year 8s, and then right above it, how many are early. If it said how many were late, then I'd simply put an 8 over the top of the 30 instead of the 22. Okay, so look at what you need, ignore everything else, and then focus your attention so you're happy with everything you've got. Okay, last question. Simone, she is a car saleswoman. In 3 months, she sold 48 cars. 3/8 of the cars were brand new. How many were secondhand? So step one really is work out how many she sold that were brand new, and then we can work out those that were second hand. So she sold 48 cars. So we need to do 3/8 of 48. That'll tell me how many brand new. Now a fraction of an amount, which we've got here, we've got a fraction of an amount number, which is guys, can you hear me? Am I back? Hello, hello. Hey, it's good. Okay, so you guys can hear me. Brilliant. I could hear something in my ear like going like dun dun. I was like, have I been kicked out of the court? Okay, sweet, lovely stuff. Right, we're on the final hurdle. We're on the final stretch. I know you guys have been listening to me for a while, so let's just quickly finish this question. So she sold 48 cars. 18 of them were brand new. So if we do 48 and subtract the 18 that we know about, we're going to be left with 30 cars. So 30 cars were secondhand. Now, I made the assumption there that you guys are all familiar with cars and that if they're not brand new, they're secondhand or pre-owned. But hopefully that didn't stump too many of you in terms of the question. But you would pick up, that's probably a 2-mark question. 1 mark for working out 18 old, 18 brand new cars, and then doing the subtraction gets you the 2nd mark. So make sure you just take your time with those questions, read it carefully, because the important bit of information there was the fact that it was the second-hand cars that we needed to know about rather than the brand new ones. So I didn't used to do this as a student, but it's something that I think I do more now, is definitely highlight keywords in a question. Okay, so 48, 3/8, second, highlight what's important, and it allows your brain to focus on relevant details rather than irrelevant details. Right, guys, let's get stuck into the question then. So we're going to look at laws of indices first. So please make notes with this because it'll help. Now, I'm just going to quickly bypass some of these. Just ignore some of these. Ignore the answers. Okay. I think by the end of this, you'll all be able to answer a question like that without much of a sweat. You look at it and be like, okay, I know what I'm doing here. So in order for us to get there, we're going to just quickly work through the rules and the laws, and then we'll be good to go. Okay. So let's get stuck in. When you multiply indices, you add the powers. Now, I do apologize if you guys have been told this recently, but it's always good to reinforce it. So 3 times 5, naturally, students will want to do this. 3 times 5, 15. That's what they'll want to do. But we need to remember this rule because this could be the difference between a mark, okay? So let me just quickly erase all the ink. So it's going to stay as y. 3 times 5, well, we add the power, so it's going to be 3 plus 5, which is 8. That's my answer. X squared times x to the power of 4 is going to give me x to the power of 6 because I'm adding the powers. And then 10 to the power of 7. Lots of students will do the natural thing and they'll times the numbers. If you can train your brain at the powers, you'll be making an advantage. You'll be taking advantage of their lack of knowledge and your depth of knowledge. Okay. Now, quickly copy down an example or two of those. And just remember that when you multiply indices, you add the powers. You add them up. Okay. When it comes to dividing indices, you subtract the powers. Okay. So when you divide indices, you subtract the powers. So here's another 3 set of examples. Y to the power of 8 so divided by y to the power, well, that means take away. So it's going to be y to the power of 6. X to the power of 5, take away x to the power of 2 is x to the power of 3. And then finally 5 to the power of 5, because we're simply subtracting. And now you guys are all capable of subtracting two numbers from each other. Just obviously pay attention to the rules and the laws. They're probably the most intriguing ones. But here we go, look at this. When we have brackets involved, what do? We multiply them. So this is probably something where you're like, oh, okay, this makes a bit more sense in terms of times in them. So x to the power of 15. Y to the power of 6. I'm timesing the two numbers together. 3 to the power of 8. So when an expression is multiplied with brackets, you multiply the powers. Okay? Give you a moment just to copy those down as well. Now remember, this video will end up on YouTube, so if I'm going too fast or you just want to watch it again just to go over things, feel free to just load it up. Okay? I'm hoping it's still recording despite my Wi-Fi malfunction, but hopefully it's still there. Okay, and the last law that I'm going to show you now, there we go, is any number or term to the power of 0 is 1. So 3 to the power of 0 is 1. 10 to the power of 0 is 1. X to the power of 0 is 1. You could have that number there to the power of 0, 1. Okay, so it doesn't matter what it is. You could have Sam to the power of 0. The answer is 1. Anything to the power of 0 will give you 1. Okay. Hopefully in your exam you never get asked what is Sam to the power of 0, because that makes no sense. But yeah, any number or term to the power of 0 will give you 1. Okay. Now what I want you guys to do now is work through just some quick questions. Just make sure your simple laws of indices skill is on point. Okay. Can you go back to the before slide? Yes, Becky. Becky, tell me which slide it was if you need me to direct again. I'm going to put a link back in the chat to Desmos where you can work through those questions. So just bear with me whilst I copy the code. Copy the code. Boom. There we go. So guys, click on that link again if you've accidentally come off. I can already see Lucy's working through some of the questions. Excellent. Remember, when we're times in indices, we add them. When we divide, we take away. When they're in brackets, we times. And then when they're to the power of 0, the answer is always 1. 1 after multiplying. Sorry, Becky. So work through those Desmos questions. They shouldn't take you too long because you've got to just do one thing. So take your time, practice. And for those watching on YouTube, here are the questions for you. Okay, let me just double check where these answers are looking. Now don't worry too much if you're struggling to submit your answers on Desmos in terms of the layout. Remember, keep the number the same. If it's like 4 to the power of something, times by 4 to the power of something, you can keep it the same. So I can see some good stuff across the board on this. But yeah, anything you're sure about, obviously make a note of it. Say, indices trip me up a little bit. Speak to your teacher or message me and I'll help you with it. I can set your century assignments directly to you. I can, obviously meet you in college next week and go over it. It's absolutely fine. Obviously, if you've got a chink in your armor, the worst thing you can do is hope that it doesn't come up because, like I say, we know some of this stuff's coming up now, so we can't really hide from it. In the summer, you might be able to be like, I'm not going to, put energy into this because it might not come up. However, in November, when we know what is coming up, we can't really hide from it. Okay, answers, guys. So bring your attention back to the PowerPoint, and then we're going to do some more advanced indices stuff after. So y to the power of 5 times y to the power of 3. Well, we're timesing them, so we're going to add them. So it's going to be y to the power of 8. We're subtracting because it's a division, so it's going to be x to the power of 7. 5 to the power of 5. 8 to the power of 6. So I'm looking at the symbol and telling myself that means add. Y to the power of 0 is 1. We're timesing these two numbers here, so x to the power of 10 to the power of 5 is going to be x to the power of 50. Remember, we're timesing those two numbers. Division means subtract, so it's going to be 10 to the power of 6. And then finally, z to the power of 20. Now, it's really difficult. I understand this because you're so used to, from day one, from maths and I was going to say maths and English lessons, from maths lessons, you're told that means times the numbers together. But when it comes to indices, we need to tell our brain, whoa, 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 whoa. No. We add them. So just for indices, when you see a multiply, you add the two powers. When you see a divide, you subtract. Okay. Now this is where we're getting onto the juicy stuff. Okay. Are you ready? So now we're going to have to combine laws. So you can see on the first example, you've got a multiply and then a divide. So let's do the top bit first. So we've got a to the power of 10 times 8 to the power of 3. Well, that means add. So 10 add 3 is 13. So I've got a to the power of 13, a over 5. What does that line mean? What does that fraction mean, guys? What sort of calculation is that? Means subtract. Well, it technically means divide, but in terms of indices, it does mean subtract. So I agree with you there. So 13 take away 5 is going to be 8. So it's a to the power of 8. Okay, so I've completed two different laws. I've added and then I've taken away, and it's the same here really. 4 to the power of 9 times 4 to the power of 3. Well, 9 add 3 is 12, so it's going to be 4 to the power of 12 divided by 4 to the power of 2. Once again, it's a divide, which means take away. So I'm doing 12 take away 2, which is 10. It's going to be 4 to the power of 10. And I'll circle that one as well. So there's my final answer. So we're combining laws. Okay, so you add and then you subtract here, and we did the same here. We added 9, add 3, and then we took away the 2. Okay, now the next one I've legitimately taken from an exam paper. So don't panic. Let's just take it step by step. And I can guarantee if you guys listen carefully now, you will have success with these questions. Now, this is probably worth 2 marks in an exam. Like I said, this is a legitimate exam question that could just be simplify this. Right, 15 divided by 3 is 5. So they're just ordinary numbers, aren't they? So we simply just do 15 divided by 3. That gives me 5, okay? Now, let's just erase that a second. Now we can look at this here. We've got x to the power of 10 divided by x to the power of 4. Well, we know because it's a divide that it means take away. So 10 take away 4 is 6. It's going to be x to the power of 6. And then last but not least, let me get my highlighter out again. I'll change the color this time. We'll go for a nice green. We've got y to the power of 7 divided by y to the power of 2. And once again, we should know that that means subtract. So it's going to be y to the power of 5. And that, I don't want to say that's it, like it's dead easy, but I've just broken it down. I've done 15 divided by 3. Then I did x to the power of 10 divided by x to the power of 4, knowing that that means subtract. And the same for y to the power of 7 divided by y to the power of 2. There's my answer. Okay, now I want you guys to give this a go and try and generate your own answers. How many have I given you guys? I've given you 5 to do. So I'll leave this on the screen just for a bit of guidance, but I will show people on YouTube the next 5 questions so they have a chance to practice. So let me just quickly get you on the right place on Desmos. There we go. Right, practice questions for those on YouTube, A, B, and C. And then on the next slide, D and E. So give them a go, get stuck in. Try and give me some answers that you think are in and around the right ballpark. So guys, keep working through these questions. Once you finish, just double check, make sure you've not made any slight mistakes. There's some very encouraging signs here, to be fair. And it might just be the fact that these look horrible and you've not seen them before, you've not attempted them before. So obviously, if this is your first time doing them, it makes sense as to why they'll be quite tricky. But what you want to do is obviously turn in an exam paper, see a question like this, and be like, oh yeah, I know what to do here. I can give this a go. So I'll give you guys another minute or two. I'll give you till 25 past. So that's another 80, no, another 1 minute, 90 seconds left. And then we'll check stuff. About 30 seconds left. So give you chances to check everything or have a drink or whatever you need to do. Have a little breather. Okay. Let's have a look at these questions then. So it's about taking it step by step. Not about trying to do it all at once and hoping for the best. It's about taking your time, remembering the indices laws, and then that'll allow you to arrive at the correct answer. So I'm looking at this first one, and I know times means add. So it's going to be a to the power of 10 divided by a to the power of 5. Now I know divide means take away. So it's going to be 10 take away 5, which is 5. So my first answer is a to the power of 5. But you can see step 1, I've added them. Step 2, I've done my division. Let's have a look at this again. So 6 to the power of 10 times 6 to the power of 3. Well, once again, we're adding them. So it's going to be 6 to the power of 13 divided by 6 to the power of 2. Well, I know that divide means take away. So it's 13 take away 2. So it's 6 to the power of 11. Then let's have a look at C. So deal with the numbers first. 30 divided by 10 is 3. X to the power of 12 divided by x to the power of 4. Well, 12 take away 4 is 8. So it's going to be x to the power of 8. Y to the power of 5 divided by y to the power of 3. Well, that's a take away. So it's going to be to the power of 2. Because 5 take away 3 is 2. So you're taking a really long sort of, formula sort of equation there, and you're just condensing it down into one line by doing those divisions and subtractions. Okay. 2 more. So this one I literally saw yesterday, and I saw it as an exam question. I was like, "Ooh, let's put this one in." So 2 times 8, right? So because there's no other number, the 2 stays the same. Okay, so that technically means 2 times 1 is going to stay the same, isn't it? So it's going to stay as 2. Now we can look at the indices. Okay, a to the power of 3 times a to the power of 2. Well, that's addition. So it's going to be a to the power of 5. Then you've got b times b to the power of 6. So we're chucking in another b essentially. So it's going to be b to the power of 7. So that one there is a legitimate exam question that I saw yesterday. So that's popped up in the past. Okay, as well as these ones with the fractions. So it depends which ones you prefer. I prefer the ones as fractions, but you may get something like that where it's a long line of calculations. Just condense it down as best as you can, and you'll probably pick up a mark or two. 20 divided by 5 is 4. 8 to the power of 8 divided by 8 to the power of 5 is going to be a to the power of 3. And then b to the power of 10 divided by b to the power of 6. Well, 10 take away 6 is 4. Boom, boom, boom. Okay. Now, my job as a teacher is obviously to try and get you marks on questions you may normally get wrong or leave completely. Now, hopefully, from what I've seen in the past, these are questions students tend to not get right or leave completely. So hopefully now we've added this to our repertoire, we can at least pick up some of the marks. Now, if you're still unsure, absolutely fine. I can go through this again with you in person or set you more questions on it, whichever you prefer. But yeah, like I say, I want you guys to be like this little dude in the corner, just working out, developing your math skill. Okay, but that's laws of indices. I've never seen them asked any harder than these 2 questions here. So if we're having success with these and getting answers similar to those, then we're in a good position. Okay, we're now going to look at ratio. Now, I love ratio, but what I want us to do is legitimately look at the more challenging ratio questions, because sometimes you see a question, I'll do it down here, share 70 into the ratio in the ratio 2:5. That's the most. So I shouldn't want to do that. I'm well good at ratio, and they could just do questions like that. Ratio develops, and it can become more interesting. Now, I'm going to show you some of the more interesting questions today, but we're going to make sure we have a strategy for it. Okay. Now, for those of you who have been taught by me in the past or now or whenever it may be, you know I love the bar method. Okay. So I draw a bar because it makes it very visual. I then split the bar up into the ratio that I've been given. So 2 to 4 to 3. So 2 add 4 is 6, add 3 is 9. So 9 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, excellent. It says biscuits, sweets, crisps in the ratio 2 to 4 to 3. So there's the 2, there's the 4, there's the 3. So biscuits for B, S for sweets, C for crisps. Now, this is the crucial bit. I've set up my bar, I've labeled it happy. Now I need to put the numbers in. I need to use this vital piece of information here to help me answer the question. Jordan spent £60 on crisps. So £60 on crisps. You'll notice that I put the £60 not anywhere else other than just next to the crisps. The aim of the bar method is to work out what goes into one of these boxes, because what goes in one of them goes in all of them. So 60 is represented by 3 boxes. Can we agree on that? Yeah, those 3 boxes there. So I need to do £60 divided by 3, which tells me in each box there should be £20. Now, like I just said, what goes in one box goes in all of them, like so. Happy days. Now it says here, now I've got that, I can actually answer any question I want. You can tell me, ask me any question about this ratio and I'll be able to give it you. Okay, so let me just quickly clear those arrows. It says here, how much did you spend in total on the food? Okay, so in total, it's the entire bar, isn't it? If it's a total, it's all of it. So I've got 9 lots of £20, which would give me £180. Another way you could look at doing this is saying, well, he's got £40 there, he's got £80 there, and then you can add up those values at the bottom. That is also fine. For me, I did 9 times 20, but if you just spent your time to do 40, add 80, add 60, we'd all arrive at the same answer. So it doesn't really matter too much. But the important thing is you've got a method here that gives you the numbers you need. I'm going to do one more example. Charlotte. So she's got a workout routine that includes squats, sit-ups, and burpees in the ratio 5 to 4 to 1. So before I've even looked at the rest of the information, I'm drawing a bar. Now, this is a terrible bar, but you get the gist of it. 5 to 4 to 1. So 5 add 4 is 9, add the 1 is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's the 10. 1, 2, 3, 4, 5. There's the 5. There's the 4. There's the 1. Hopefully your drawings are much better than mine. So we can actually just label it squats, sit, ups, burps. I'm going to put burps. Okay. Charlotte complete. Now, look, I've labeled it. I've set my bar. Now I can look at the rest of the equation. What's important? What numbers do I need to put where? Charlotte completes 80 squats. 80 squats in one session. How many burpees did she do? So squats is here, represented by the number 80. I need to divide that by 1, 2, 3, 4, 5. So I need to do 80 divided by 5. Now, remember, this is a non-calculator paper, so if you need to, whack out the bus stop method. So we're doing 80 divided by 5. So 5 on the outside, 80 on the inside. 5's into 8 go 1, remainder 3. 5's into 30 go 6. 16 bits of exercise in each part. Okay, so 16 in each one. Boom, boom, boom. Now it takes a little bit of time, but I tell you what, the examiner will be like, hey, this student, they know what they're doing here. They've got the bar method on point. They're good. How many burpees does she do? So now that's where I bring my attention to the burpees part of the ratio. I look at how many they're there. There's 16. So it's just the answer of 16. But the good thing is, if it said how many sit-ups did Charlotte do, well, I'd look at the sit-ups then, wouldn't I? And I'd say, right, let's have a look. She did 1, 2, 3, 4 lots of 16, which is 64. So I can answer pretty much anything. If you've got this bar method, you know, on point, you've pretty much got the answer to any ratio question they could ask you about that particular question. Okay, so guys, that is what I want you guys to practice. So you've got a few here. Now those last two are exam questions. That one is an adapted exam question, and that one's one I made up. So you've got 4 questions to do. The last 2 are pretty much spot on exam questions. So let me get you back onto Desmos. And then for those watching on YouTube, I'll show you the questions in a moment. And then we're going to look at some funky ratio stuff in a second. Okay, so for those watching on YouTube, there's the first question for you. Second question for the YouTubers. So take your time, work through these as carefully as you can. Pen and paper, get that bar scribbled out, and you'll see how it gives you the right answer every time. Question 3 for the YouTubers. And then finally, question 4 for the YouTubers. So just as a heads up, everyone who's answered question 1 has got it spot on. So you've got a method that looks to be working. Just try and look for that consistency now, okay? Now, if you need to use the bus stop method, use it, okay? I'll be using non-calculator methods throughout this PowerPoint. So you guys do the same, and then we're all equal. I'll give you guys another 2 minutes or so to look at these questions. Remember, draw the bar, label it, then the information you're given, try and put that information in the right place. If you put it in the right place, the rest of the question should become that a little bit nicer. You'll see the last two are legitimate past questions from an exam. So I've not made them up out of my own stupid brain. I've made them up from AQA. Okay. Give you 1 more minute just to finish these questions off, and then I'll go through them. Now, I'm tempted to not go through question 1 because you've all got it right, but those on YouTube need to know the answer, so I will have to quickly browse through that one. Then I'll look at the other ones just to make sure you guys are happy with the method and, you know, check what you might have done differently to me, sort of thing. Okay. Right, let's have a look at these questions then. So step 1, you see a ratio. Worst case scenario, just draw a bar, because the bar just gives you some structure, and it's a method. So 5 to 2, that's 7 parts. 1, 2, 3, 4, 5, 6. There's the 5, there's the 2. Label it. So Tommy and Teddy. So there's Tom, we'll put. There's Teddy, we'll put Tom and Ted. Tommy's given £35. So next to Tom's name, £35. I need to split that into 1, 2, 3, 4, 5 boxes, because that's I don't want to give any of Tom's money to Ted. That stays for Tom. So I need to do 35 divided by 5, which is 7. And what goes in one box goes in every box. So our guy Ted over here, 2 lots of 7, £14. Ta-da! Done. And you all got £14. I'm not going to spend too long on that. Happy days. The shop sells red roses and white roses in the ratio 7 to 2. One day, 84 red roses are sold. How many white roses are sold? Okay, so draw a bar. 7 to 2, that's 9 parts together. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's the 7, there's the 2. Oh no, whoa. I need to label it. Red and then white. So red roses are R. White roses, WR. One day they sold 84 red roses. So next to the red roses, I put the number 84. I'm dividing that between 1, 2, 3, 4, 5, 6, 7 boxes. 84 divided by 7 is 12. So 12 in every box. Boom, boom, boom. Like so. Now I know that, I can actually answer this question. How many white roses were sold? Well, that's 2 lots of 12, which is 24 white roses. So once again, draw your bar, label it, identify the key piece of information in the question and put that next to the corresponding part of the bar that you've drawn, and then do a division. Once you've got that division, I think the rest is quite self-explanatory in working out what you then need to know. Okay. These are the legitimate exam questions now that I've taken from AQA. So let's have a look at how, like literally, this is what I would do in an exam. Peter and Alice buy a set of golf clubs for their mother. They pay in the ratio 4 to 3. Peter pays £224. How much does Alice pay? Well, here you go, son. Here's a bar. 1, 2, 3, 4, 5, 6, 7 parts to represent the ratio. 4 to 3. Peter and Alice. So Peter's name comes first. So he's there. Alice next to him. Peter pays £224. So there's the £224. 1, 2, 3, 4. So 4 boxes. So I'm going to do 224 divided by 4. Now, forgive me for not knowing this instantly. I'm going to do a little bit of bus stop method. 4's into 2, go 0, carry the 2 over. 4's into 22, go 5, remainder 2. 4's into 24, go 6. So £56 in each box. So Alice, she pays 3 lots of £56. So once again, draw a little multiplication. Like I said, this is exactly what I would do in an exam. 3 lots of 56. So that's going to be 150. That's going to be 18. And then we're going to add those two values together. Bada bing, bada boom, £168 our good friend Alice pays. And do you know what the examiner's gonna, they'll sit back and they'll start clapping me for that beautiful working out, because they'll be like, this guy, he's got his bar method looking good, his division's looking good, his multiplication's looking good, give him the marks. Now I believe that was a 3-mark question in an exam from what I saw yesterday. So 3 marks, because it shows you've understood ratio, you can do your division and your multiplication. Happy days. Okay, so give yourself a pat on the back. Now this one's a banger, and you can see here it's a 3-mark question. Hopefully you can see that, 3 marks. Smoothie recipe uses banana, kiwi, and yogurt in the ratio 4:1:3 by weight. So draw a bar. It's a super long bar, this one. 4 add 1 is 5 add 3. So that's 8 parts. 1, 2, 3, 4, 5, 6, 7. Okay. There's the 4, there's the 1, and there's the 3. And it's banana. So I'm going to put B, K for kiwi, Y for yogurt. A smoothie is made using 280 grams. So 280 grams. So yeah, the gist of it is what goes in these boxes here. So there's only 4 boxes for banana. So I need to do 280 divided by 4. Well, 28 divided by 4 is 7. Chuck a 0 on. 70 grams. 70 grams in each. Oh, there's a guy just knocked on my door. I'm gonna ignore him. You guys are my priority. Right, kiwi is worth what? Just 70 grams. Kiwi, 1, 2, 3. 3 lots of 70. Well, 3 lots of 7 is 21. Chuck the 0 on. 210. 3 marks. Probably get 1 mark for 70. Actually, I don't know where you'd. I can't remember the mark scheme, but you definitely pick up a mark for doing 280 divided by 4. That would get you a mark, and then the 70 would get you a mark, and then the 210 would get you a mark. So just process of just having a method that works really does help. Now, what you'll be glad to know is that this bar method helps you with other questions as well. So let's have a look. This is my one I'm going to work through, and then I'm going to give you guys 3 to do. Okay? Don't know who's at my door. It's one in red. Anyway, in a school show, girls to boys is 1:1. Girls who sing to girls who do not sing is 1:2. 8 girls sing in the show. How many students are in the show altogether? Whew. Okay, are you ready? So let's start at the top. We'll draw a bar, split it up into 1:1. So that's 2 parts. Girls, boys. And I might not be lazy here actually for this example and label it properly. Girls to boys. Now, draw another bar to represent the other ratio. That's 3 parts, 1:2. So 1, 2, 3 parts. Girls who sing, girls who do not sing. Okay, so that's 1:2. So, whoops, let me just label this properly. So I'm going to put sing, G sing, G not sing. Hopefully you understand G means girls, so girls not sing. Okay, are you ready? 8 girls sing in the show. So the girls who can sing are there. So there's 8, and that just needs to go into 1 box. So 8 divided by 1 is 8. What goes into 1 box goes into all of them. So I've got 8 girls who sing, 16 girls, or 2 lots of 8, 16 girls that do not sing. How many girls do I have in total? I'm going to come to the chat for this. I'm going to be lazy. How many girls are there in total then? I've got 8 who do sing and 8 who don't sing. How many do I have in total? What are you guys thinking? 24. Excellent. So I've got 24 girls who sing. 24 girls in total. Now remember here, this is where our first ratio comes in. I know the number of girls now, so now I can know the number of boys. If there's 24 in this box, there must be 24 boys because they've got the ratio of 1:1. So it says how many students are there all together in this show? Well, I've got 24 girls, 24 boys. I have 48 students in total. So you can see there, I started with 1 ratio and 1 part of the ratio. It allowed me to work out the other bit. They gave me information for all the girls, which then told me how many boys there are. And granted that there's no, elephants or anything like that in the show. There's just 48 students. Happy days. Now, this is where I want you guys to explore ratio now. Like, there's no pressure in terms of you need to get this right, but I want you to give it a go and see what numbers you can generate for the next few questions. Okay. Now, I particularly like these questions because it really does kind of reinforce and support the use of the bar method. I will be going through each one of these. So let me just get you guys onto Desmos in the right place. I just want you to give them a go. Okay. So, in a school show, oh no, sorry. For YouTubers, here's question 1. Give you a chance to look at that. Pause the screen if you need to. Question 2. And then finally, question 3 for my YouTubers. So get stuck in, give these a go. Like I say, you've got nothing to lose at this point. I'm not going to hold it against anyone if they're struggling. Okay, guys, 2 more minutes. So at 11:56, I will go through these answers. Okay. 11:56. Let's have a look at these questions then. So bring your attention back to the PowerPoint. Now these are tricky, so don't worry if they've stumped you at all, because these, like I say, these are the sort of questions students leave. 3 teams, A, B, and C, play in a competition. Games won by A to games won by B in the ratio 2-1. Games won by B to games won by C 3-1. Team B has won 6 games in total. How many games have the 3 teams won? So let me get my pen ready. Here we are. So games won by A, games won by B. So I'm going to draw that as a ratio, or draw it as a ratio. So 2-1, so that's 3 parts, and it's 2-1. So A wins, B wins. Games won by C, B to C, so that's 3-1. That's 4 parts. 1, 2, 3. Okay, and that's 3-1, and it's B wins, C wins. Okay, Team B has won 6 games. Okay, so that's actually quite nice, because here it says it tells us what Team B wins. So we can put 6 here in the one box, can't we? So that means there's 6 in each of those. So Team A won 12. Team B won 6. Okay, that's good. I might make a note of this actually. A equals 12. B equals 6. Now I just need to do C. Now remember, this is the ratio for B to C, and it says they won 6. So 6 here. Now I need to divide that into 1, 2, 3 boxes, which means there's 2 wins in each. What goes in one box goes in all of them. So C, unfortunately for Team C, they only won 2 games. So they're the wins. A won 12, B equals 6, C won 2. In total, how many games have the 3 teams won? So I need to add them up, don't I, to get the total. 12 add 6 is 18, add 2 is 20 wins. So it looks like a really horrible, awkward question. The amount of ratio symbols we can see looks pretty heavy. But if you draw it visually and then get the numbers in the right place, it kind of just flows, and the numbers kind of just fall into place. Hence why I like the bar method, because sometimes the hardest part is actually drawing the bars. You can see I struggle to draw a straight bar here, but yeah, there we go. So 20 wins in total. But if you managed to pick up 12 or 2, you'd have picked up marks, and I believe that would have been at least a 3-mark question as well. Right, let's finish the ratio stuff with these 2 questions now. So 3 angles are in the ratio 2 to 3 to 7. So we're going to draw a bar. 2 to 3, that's 5, 7, that's 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Squeeze that in at the end. So it's 2. There's the 3, there's the 7. The smallest angle is 60 degrees. 60 degrees. So the smallest part of this ratio is the 2. So the 60 degrees goes there. That must mean, well, 60 divided by 2 is 30. So in each box, we have 30 degrees. Now, it takes a little bit of time sometimes when it's a big ratio, but hopefully now you can see there's 3 lots of 30 there, so that's 90 degrees. And then 1, 2, 3, 4, 5, 6, 7 lots of 30 is 210 degrees. Now it says it show that these 3 angles will fit together at a point with no gap. So angles around a point add up to 360 degrees. So what I need to do here is show that these 3 numbers add up to 360. So 60, add 90, add 210. 0 at the end. 6 add 9 is 15, add the 1 is 16, carry the 1, 2 add 1, 360, boom, 360 degrees. Thank you kindly. So yeah, what's the marker the examiner going to be looking for there? He's going to be looking for your ability to get to 90, 210, and then the 360. They need to know that you know that angles add up to 360 around a point, okay? This is the last one. I think the most tricky because it's kind of misleading here. In a right angled triangle, the smallest angle to the largest angle is 2 to 5. Work out the 3 angles. Now, what you need to know is that in a right angle triangle, the biggest angle is the right angle, 90 degrees. You can't have it any bigger. That's a smaller angle on that one. So when you draw in your bar, 2 to 5, that's 7 parts. 1, 2, 3, 4, 5, 6. There we go. There's the 2 and there's the 5. The biggest angle, let me put small, large. The largest angle has to be 90 degrees. You can't have these angles being any bigger because then it would no longer be a triangle. Okay, so that's your biggest angle. That's 90 degrees. You can do 90 divided by 5 is 18 degrees. So 18 degrees in each box. That means this one, the smallest angle must be 36 because 2 lots of 18 is 36. Now, we know one angle is 36, we know the other's 90. By process of elimination, we can then work out the final because we need all 3 angles, don't we? So if I do 90, add 36, that gives me 126. And then if I do 180 degrees, the number of degrees in a triangle, take away 126, that'll tell me the leftover missing one. So 0 take away 6, I can't do, so I'm going to borrow from the left. 10 take away 6 is 4. 7 take away 2 is 5. 1 take away 1 leaves me with nothing, so 54 degrees. So my 3 angles are 36 degrees, 54 degrees, and 90 degrees. That is a tricky question though, because without that bit here, knowing that the largest angle in a right angle triangle is 90, that question becomes very difficult. But what was the first thing that I did, guys? I drew a triangle. I drew a right angle triangle, which hopefully kind of can spur ideas that, oh yeah, the 90 degrees, that must be the biggest. But that's something that maybe we need to tease out of students in future to say, oh, what is the biggest angle in a 90 in a right angle triangle, and make people think a bit differently. Okay, but what I was going to say, I've been thinking about this as you guys have been working. Amounts as a percentage we've not got on to do, but hopefully you can see I have had the questions here ready for us to use. So I'm going to record a video on this and upload it later because I don't want to keep you guys waiting to lunch, because I know concentration after an hour and a half does tend to dip and the learning that's taken place could suffer because of it. But I'm happy to record a little YouTube video, share it with you guys in preparation for next Tuesday. I'll go through some example questions, give you guys some to do yourselves, and then you can check your answers against me. Okay, so I'll upload that later. Thank you guys for tuning in and listening and watching today. You guys have been excellent. It's been, I know online lessons are tricky, especially doing stuff that we've not done before and tricky things as well, but you guys have been awesome. So I'll end the session there. It's just gone 12 o'clock. Any questions about anything we've covered today, drop me a message on Teams. My name is Sam Parry. I'm pretty sad and I reply pretty much most of the time, even in the late hours, because that's the guy that I am. So yeah, drop me a message. Anything you're unsure about, I'm happy to help with, and I'll see you guys soon. It also looks like my laptop is frozen. Brilliant. So guys, feel free to leave the call. Enjoy the rest of your day and drop me a message if you need any help or support with any of the content today. Okay.